So what is trigonometry all about? Well, let's describe it by trying to work out the solution to this problem. Let's imagine you wanted to climb this mountain. So that's the base of the mountain there, and that's the top of the mountain, and that's you at the bottom, and you've got a rope. But in order to get up the mountain safely, you're going to have to make sure that the rope is long enough so that whenever you peg it in, it'll take you all the way to the top, and then what you want to do is just abseil all the way back down again. But how do you find the height of the mountain? Well, you could climb the mountain, but then that defeats the purpose because you're going to climb it unsafely and you don't know whether the rope is long enough. Or you could take a helicopter to the top and drop a rope down and measure it, but that's cheating and you're not allowed to do that. And what if the mountain was, say, 5,000 feet high? You would need a 5,000 feet length of rope, which is going to be really heavy, so it's just not really feasible. So you need to find some other way of finding this height, and that's what we do with trigonometry. So let's imagine you actually had that problem. What you could do is you could put together a little apparatus like this. Now we've got a protractor here. Now the protractor has got a half a circle. Now each point along the circle is split into 180 little points. Okay, so it goes from 0 round to 180. So that's called 180 degrees. Now what I've done is I've stuck a straw on this protractor with a couple of pieces of blue tack, and you could use this in order to actually solve that problem. So if I was to take the straw, and if I was to put the straw on at a particular angle, so if I put the straw on at exactly 45 degrees, now 45 degrees is halfway between the horizontal and the vertical. So if it's halfway between the horizontal and the vertical, it means when we run up along this straw, if we were to say go along 1, we would be going up 1. If we went along 2, we would be going up 2. If we went along 3, we would be going up 3. So the distance along here would equal the distance up here. So now we're looking at this thinking, I've got a solution to this problem then. What I can do is, I can take this little apparatus here, and I can put it along the ground, and I can just move it along like this, and I can look in this end here. So that's you looking up inside the straw. So look, so you can see inside the straw, and you would take the straw, and what you would do, you would line up the straw with the top of the mountain. So you would stand in there, and you start walking back, and you keep walking back, and you would look and you'd say, well, is this lined up with the top of the mountain? So well, it's not lined up with the top of the mountain yet. So you would just keep walking back, and you would keep doing it, and you would keep walking back, till eventually you get to a point there, and again, you're just using a bit of guesswork and common sense, but you get about a point, say there, and when you look into the bottom of your straw there, and then you look all the way up there, then that point there will line up with the top of the mountain. Okay, so I could draw a wee line up like that, and that would go in a straight line up to the top of the mountain. Now, we know, because that's 45 degrees, that this length here must be equal to that length there. So all we need to do is measure the length from the base of the mountain to this point here where our eye is, and we know that that distance there will be the height of the mountain. So that's a basic bit of trigonometry. So let's write that out in a kind of mathematical way. So if we were to say that the height of the mountain is y, so that's just this height here, and the length away from the base of the mountain to the bottom where our eye is, if we call that distance x, then we have a y distance, an x distance, an angle of 45 degrees. So we could write out in words the ratio of the y to the x at 45 degrees equals 1. So what we're saying is, if we go along 1, we go up 1. If we go along 2, we go up 2. If we go along 3, we go up 3. If we go along the length, this length here, to that point there, that length there is the height of the mountain there. Now, we don't want to just endlessly write the ratio of y to x at 45 degrees equals 1. Because you imagine doing lots of problems here and you're just endlessly writing that same line out, the ratio of y to x, the ratio of y to x, the ratio of y to x. It would just get silly. So what you do is you take these words, the ratio of y to x at 45 degrees equals 1, and you give it a name, and the name that you give it is called the tangent, and it's shortened to tan. So what we would write is tan 45 degrees equals 1, where tan is these words here, the ratio of y to x at, and then the 45 degrees is the 45 degrees, the equals is the equals, and the 1 is the 1. So that's the basics of trigonometry. So let's continue with this. Now, if it turns out that this mountain, say for example, is something like 5,000 metres high, that would mean you'd have to walk 5,000 metres this direction with a little piece of equipment like that at 45 degrees in order to have measured that height. Okay, so that distance there would be 5,000 metres, then that distance there would be 5,000 metres. Now, let's say you don't want to walk 5,000 metres because it's just too strenuous, or maybe you can't walk 5,000 metres because maybe somewhere along there there's a forest, or there's maybe a river, or it's a city or something, so you just can't get past that point. Okay, so you don't want to have to walk 5,000 metres. So then you think to yourself, well, what I could do is I could adjust it, I could change this here. Instead of making it 45 degrees, okay, I could adjust it round to 60 degrees. So if I adjust this round to a much sharper angle, okay, a bigger angle, that means I can get closer to the mountain and measure the height. Okay, so it means instead of being way back here, you can go closer to the mountain. And if you go closer to the mountain, you can go there and you can keep moving back and back and back and keep doing that until eventually, when you look through the bottom here, the bottom there is going to line up with the top there. Okay, so I can now draw my line up there like that. And we're now at this point here, so I've only needed to walk back to this point here. So we haven't needed to walk all the way back to here, we've just needed to walk back to this point here. But that means that if we were to redraw this out again on a piece of paper, we would end up with something like that. So we would have the y distance would be the height of the mountain, and the x distance would be how far back we have walked. And this angle here would now be our 60 degrees. But we know that if we were to measure the ratio y upon x, so if we measured that y there upon x there at 60 degrees, we would get a value of 1.73. Now you can try that yourself. You can take a protractor and you can draw a triangle out at 60 degrees, and you can make the y and the x distances whatever you want, as long as the angle remains at 60 degrees. Then if you measure this distance to that distance, you'll get 1.732, which is actually root 3. Now the same way would happen if you measured this distance here to this distance here. You would get root 3, or if you measure this distance here to this distance here, you would get root 3, because these triangles are all similar. So it means then that we can work out the height of this mountain at 60 degrees if we just notice that the ratio of y to x at 60 degrees is always 1.732, which is root 3. Now, we don't write the ratio of y to x at, we replace that with this thing here called the tangent. We call it tan, and we say the tan of 60 equals root 3. Okay, so then we're left saying, well, what height is a mountain? Well, whenever we go through this example here, and I'll measure along there, well, that's approximately 10 centimetres. Okay, So x equals 10 centimetres. So it means that we can then say that, well, we know that y is going to equal the root 3 times the 10, which equals root 3 times 10 is approximately equal to 17. So that's 17 centimetres, and that height there is 17 centimetres. If I measure up there, that height there is the 17 centimetres. So if we were to write it out in terms of a mathematical way, we could say that y upon x equals the tan of our 60 degrees, and then we can say y, the height, will equal our x distance times the tan of 60 degrees. Now we know the tan of 60 degrees is root 3, so we just say that y equals x, which in this instance is 10. Y equals 10 tan 60, and 10 tan 60 is 10 times root 3, which is equal to 17. So that's all we're doing whenever we're looking at the tangent of 60 degrees. Now you could then look at that and say, well, I could extend that to every angle. I could say, well, what's the tan of 1 degree? What's the ratio of this y upon x for 1 degree? Now 1 degree, it would be very, very small, because it would be this length here upon that whole length there. But as it get bigger, this length here would get a little bit bigger, and that length there would remain the same. Okay, so it means that we can then work out the value of tan for every single angle all the way round in a full circle, all the way around 360 degrees. Now finally, before we go on to the simulation and the graphical calculator and we start building it up, we can then look at the other two functions, which are the sine and the cosine. Now when we looked at our triangle here, or if you like, the height of our mountain and the distance away from our mountain, we looked at the ratio y upon x for every value of our angle theta. Now we didn't need to just look at y upon x. We could have looked at two other ratios. We could have looked at the ratio of the y upon r. Now we give that ratio y upon r another name, and we call it the sine. So instead of writing out the ratio of y to r at, we replace that with the word sine. Now the same goes for the second one here. We can look at the ratio of the x to the r, and we call that ratio x to r the cos of the angle theta. So rather than writing out the ratio of x to r at, we replace that with the words cosine is shortened to cos. So we say x upon r equals cos theta. So we're going to look at all three of these ratios, x upon r, y upon r, and y upon x equals tan theta. So we're going to look at these in the graphical calculator, and we're going to see exactly what they look like.